All right, ladies and gentlemen, I hope you're having a great day. I think all this homework should have been pretty straightforward and simple. All you had to do is remember that the three angles inside any triangle add up to be 180, and also, the Pythagorean theorem and the basics with that. I know that some of the problems, 38 and 40 got a little bit more involved, but otherwise these were pretty straightforward stuff. So we're going to get rocking and rolling. These first three all dealt with this triangle ABC that had a altitude running to point D, and it has these Greek letters, lowercase alpha, and beta. And so we're going to get rocking and rolling, and let's make sure you got these right. I'm only going to move through them real quickly because I think they're pretty simple. Okay, it says, what if beta is 45 degrees? What would B be? Well, if that's 45 degrees and then we got a 90 right here, that would only leave 45 degrees for B. Okay, so that would make it a 45, 45, 90. Pretty simple. Okay, let me get rid of that. Okay, it says, what if A was 2 alpha? What would alpha be? So if this was 2 alpha, well, we know that this over here would be 90. So what you do is you say, well, I know that 2 alpha plus 90 all has to equal 180, which is 3 alpha plus 90 equals 180. So therefore 3 alpha is equal to 90, meaning alpha is 30. Okay, so that's pretty straightforward, 30 degrees. I know that one had a little bit more going on, but still not too bad. Next one, let me erase this right here. Okay, next one said, what if alpha plus beta equaled 80? And so what we're saying this angle right here is 80 degrees, and A is 80 degrees. Then what would B have to be? And that's really simple, because now, even though it doesn't look like it at all, that would be an isosceles triangle. It has two congruent angles, must have two congruent sides. And so what we're saying is we'd have an 80-degree angle plus an 80-degree angle plus whatever B is, and that would all have to add up to be 180. Well, this is 160 plus B is equal to 180. You could subtract the 160 from both sides, and you get that B is equal to 20 degrees. It's that simple. All right, let's move on to the Pythagorean theorem, okay? This first one, it says 6 plus 8 squared is equal to c squared. And I'm sure you all figured this one out really fast. You get 36 plus 64 is equal to c squared. That is to say that c squared is equal to 100, so therefore c is 10. Now, if you did the whole c is equal to plus or minus 10, you don't have to do that because we're talking about length of sides. And so we don't have to do the plus or minus 10. We end up with that c is 10. Okay, next one, we're trying to figure out b while given c. So we say 2 squared plus whatever b squared is equal to 6 squared. So that's saying 4 plus b squared is equal to 36. So therefore b squared is equal to 32. B is equal to the square root of 32. And you can simplify that a little bit because I know that that's the same thing as 2 times the square root of 16. So therefore that's 4 times the square root of 2. The 16 came out and the 2 stays behind. So b is equal to 4 times the square root of 2. Number 30. Again, we're this time we're given the hypotenuse, but we got to figure out a. So we have a squared plus 10 squared is equal to 26 squared. This is a Pythagorean triple, so this is a kind of a nice and easy one. A squared Pythagorean triple means 3 whole numbers that fit into the Pythagorean theorem. Plus 100 is equal to 676. Okay, you subtract 100 from both sides, you get that a squared is equal to 576. And so that is the square root of 576 is 24. Okay, so a is 24. All right, so let's move on. Let's see here. Number 32. 32, I'm not sure if anybody recognized it, but because you have a 5 here and the hypotenuse is 5 times the square root of 2, that makes this a 45, 45, 90. And so therefore, without even doing any work, I know that this is 5. But let's say I didn't notice that. I would have 5 squared plus x squared is equal to 5 times the square root of 2 squared. Now, I'm guessing that some people would kind of maybe mess that part up. 5 squared is 25, x squared is just x squared. In this one, 5 squared, 25, square root of 2 squared is 2. So you get 25 plus x squared is equal to 50. Subtract the 25 from both sides, you get x squared is equal to 25, so therefore x is 5, just like we said it was. Okay? see here, get rid of all this. Okay, delete. All right. And then let's see here. This next one, because this side is 1 and the hypotenuse is double, that makes this a 30, 60, 90. Okay? And so therefore, I know that this is equal to square root of 3. But even if I didn't know that, I could say, well, 1 squared plus x squared is equal to 2 squared. Subtract the 1, which obviously is 1 plus x squared is equal to 4. So therefore, x squared is equal to 3. So x is equal to square root of 3, just like we said it was. Okay. All right, on number 36, this one becomes a little bit more challenging because we have x in a couple different spots, and we have this binomial down here, and some people might mess that up when squaring it, but it should be x minus 1 squared plus x squared is equal to 5. I'm going to go ahead and FOIL this first one out and get x squared minus 2x plus 1 plus x squared equals 5. Combine like terms, 2x squared minus 2x plus 1 equals 5. Move everything over to one side. 2x squared minus 2x minus 4 is equal to 0. Divide everything by 2. X squared minus 1x minus 2 is equal to 0. So you go, what are factors of negative 2 that add up to be negative 1? And that would be negative 2 and positive 1. So I go x minus 2 times x plus 1 is equal to 0. And if that's the case, then either x minus 2 is equal to 0 and x is 2, or x plus 1 is equal to 0, and x is negative 1. Well, this can't be the case because it's the length of a side, so therefore x must be 2. All right, and now we're down to the last two. These are probably the most complicated way you can use the Pythagorean theorem, but that doesn't make them hard. Okay, they're still very doable problems. All right. Let's see, this first one, we're looking for this middle hypotenuse, and so that can be kind of weird. So really what you have to do is you go, first I've got to figure out what this whole side would be. I've got 2 sides of a right triangle. I need to figure out that third side, okay? And so that means I would look and say 5 squared plus some unknown squared is equal to 13 squared. 5 squared is 25, x squared is x squared, 13 squared is 169. If you subtract the 25, you get 144. And then you square root both sides, you get x is equal to 12. Now what that is to say is that this whole thing from here to here is 12. And if this part is 4, then that leaves 8 for right there. And so then you have 8 squared plus 5 squared is equal to this unknown that we're looking for, say BD squared. Okay, so that gives me 64 plus 25 is equal to BD squared, which is 89 is equal to BD squared. So therefore, BD is equal to the square root of 89. All right. Like I said, those are probably the most complicated Pythagorean theorem problems, but I think you guys can still do it. Okay, let me move this out of the way a little bit. Okay, scoot over there. All right. And then I love these because they look so much harder than they are. These are really not hard. The r squareds always drop out, so it makes these so much easier. We got to figure out what r is. So we know that r squared plus 12 squared is equal to 8. I'm going to switch that around. Is equal to r plus 8 squared. So this r squared plus 144 is equal to, on this side we got a FOIL, r squared plus 16r plus 64. Subtract the r squared from both sides, those cancel out. Subtract the 64 from both sides, and that's gone. And so we get 144 minus 64 is 80 is equal to 16r. Divide both sides by 16, and we get that r is equal to 5. All right, I hope that worked out for you. I think, like I said, I think these are pretty straightforward. And so today we are going to try some new things, some old things, and some new things involving algebra as we move forward in this. Hope you have a great day.